Hello and welcome to today's lesson where we'll explore the concept of transmission as part of our study of waves. We will begin today's lesson by learning how partial absorption occurs during transmission. We'll then explore how different materials affect light transmission. Finally, we'll discuss everyday examples of transmission and briefly touch on refraction. So far, we have focused on reflection and how to construct ray diagrams. We have also studied how waves can be absorbed by materials, converting energy into other forms. Building on this foundation, we can now delve into transmission to enhance our understanding of how waves interact with different materials. Transmission is a process whereby a wave passes through a substance and comes out on the other side. For instance, when light waves travel through a glass window, they are being transmitted by the material of the glass. It is essential to note that as waves transmit through a substance, they do not emerge on the other side perfectly intact. During transmission, some part of the wave's energy is absorbed by the material. This absorption leads to a reduction in the amplitude of the transmitted wave. For example, when you hear a sound on the other side of a wall, it's quieter than when you're directly next to the source. This is because part of the sound wave's energy is absorbed by the wall, reducing the amplitude of the sound wave that emerges on the other side. In the case of light, the amount that is transmitted through a material depends on the material's transparency. A transparent material, such as glass or clear plastic, allows most of the light to pass through with minimal absorption. In contrast, translucent materials, like frosted glass, allow some light to pass through, but the light is scattered in different directions. This scattering makes it difficult to see clear images through the material. You can see that light is coming through, but details and shapes appear blurry. Opaque materials, like metal or wood, do not allow light to pass through at all. Instead, they absorb or reflect the light. Transmission is a phenomenon we observe in many aspects of daily life. Here are a couple of examples. Windows are designed to be transparent so that visible light can be easily transmitted into our homes, providing natural light. Used in telecommunications, fibre optics are specialized cables that transmit light signals over long distance with minimal loss. Light waves travel through these fibers, allowing for rapid data transmission for internet and phone services. While discussing transmission, it's crucial to touch upon the concept of refraction. Refraction occurs when a wave changes direction as it passes from one medium to another. This bending happens because the wave changes its speed upon entering a different material. For example, when light moves from air, a fast medium, to water, a slower medium, it bends at the interface. This effect can be readily observed when a straw or spoon appears broken when placed in a glass of water. The light waves transmitted through air and water travel at different speeds, causing the bending of light rays and thus the distorted appearance. We will dive deeper into refraction in the electromagnetic waves section to fully understand how varying wave speeds in different media lead to this phenomenon. In today's lesson, we delved into the concept of wave transmission. We began by defining transmission as the passage of a wave through a substance, emerging on the other side. We discussed that during transmission, waves often undergo partial absorption, leading to a reduction in the amplitude. We examined how the transparency of material affects the amount of light that is transmitted through it, with more transparent materials allowing more light to pass. We also touched upon refraction, explaining how the bending of light occurs due to changes in wave speed when moving between different materials. Understanding transmission and refraction is key to grasping how waves interact with materials in everyday life. Watch the rest of the GCSE Physics course at Sophos Education.